So in this video, we're going to talk about ratios, proportions, and geometric means. It's going to start of our second half of this unit. Your objectives is you can find and use ratios to solve problems, and you can solve proportions, and you can find geometric means. We have dealt with ratios in the past with previous activities and projects we've done, but we're just going to look at it a little more closely. So a ratio is a quantitative relation, which just deals with numbers, between two amounts showing the number of times one value contains or is contained within another. So for example, if I have 3/4, I can put an x by each of these. When x can represent, so x equals any number. Okay? So I can keep the same proportion. So if I say x in this case is 5, the ratio 15/20 also works because this reduces down to 3/4. Another way to look at it, that for every 3 of something I have, so if I have 3 circles, 3 red circles, for every 3 red circles, I have 4 blue circles. So if I have 4 more blue circles, that means I have 3 more red circles to keep the same proportion. Over here, 3/4 or 3/4 is another way we write ratios. So in A, what is the ratio of the length to the width of the following rectangle? So your length, as we're going to say, is 5, and your width is 2. So it is 5, 2, 2. Okay? Or we can go 5/2. Either one works. So on the bottom, we need to simplify ratios. So first, when we want to simplify ratios, they need to be the same unit. So on B, we have 2 centimeters. So then we're just allowed to simplify by dividing both by the same number. They are both divisible by 4. So I can simplify that ratio. 4 divided by 76 is 19. 2. 2. Or you can write it as 19/2. It can be written as fractions or with a colon. C is a little different because they are not of the same unit. We have feet and inches. So then I need to convert. So I need next to it multiply by the conversion rate. So in here, for every 1 foot, it is 12 inches. Okay, my units cancel out. So we get 48/24, and you should have already did this in science, so it should be a review, which gives me 2/1, or 2, 2, 1. That's my ratio. 19/2. Alright? So our next example, we're actually going to have to figure out the lengths based off the ratio. So the perimeter of the rectangle table is 21 feet. So remember, perimeter is your distance around the figure. And then the ratio of the length to the width is 5:2. So we have the length here and the width here to find the width of the table. So remember, 5/2 can be written as 5:2 or as 5/2. And that remember, a ratio means for every 5 you have 2. So for every 5 of the length, and we're going to put x next to it because we don't know how many sets of 5, there are 2 here. And 5 is your length and 2 is your width. We could also write it over here where we could go 5x and 2x. So remember, perimeter is 21 feet. So perimeter is adding up all the sides. So we can treat this as like 5x and we're going to treat this as 2x. Alright, so we can add up. So 2x plus 2x, my two width sides, plus 5x plus 5x equals 21. And then all we have to do is solve for x, and then we can get our side lengths. So we have a total of 14 x's equals 21. Divide by 14. X equals 1.5. Alright, so then we're partially done. Now we just need to figure out what our length and our width is. We can just plug 1.5 into our two x's, and we have our length equals 5 times 1.5 is 7.5. And our width, 2 times 1.5 is 3. And you could check by adding this up. 7.5 plus 7.5 is 15. 3 plus 3 plus is 6, which adds up to 21 feet. So we have the correct answer. Alright, so we're going to be doing a lot of solving proportions and setting it up. And when we solve proportions, which we kind of did a little bit already this year, is you want to cross multiply. So cross multiply means you multiply the two corners. So the numerator and the denominator on the opposite side. To do this, you do need an equal sign in the middle for us to cross multiply. So this means that AD equals BC. So we're going to, for example, we're going to solve the proportion. So we're going to cross multiply. So we go 8 times 5, which is 40, equals 2y. We divide by 2. Y equals 20. Alright, so then on the next one, we're going to cross multiply. So we have 9 times x minus 3. And 3 times 2x is 6x. We distribute, so we have 9x minus 27 equals 6x. Subtract 6x. Actually, I'm going to subtract 9x I want to do. So to have less steps, so we have negative 27 equals negative 3x. Divide by negative 3. Negative 27 divided by 3, x equals 9. And a way you can check this is by plugging it in. So if I would plug 20 into here, 8 over 20 simplifies down to 2/5 because they're both divisible by 4. Alright. Same thing here. If I plug in 9, I get 6 over 3 and 18 over 9. They both simplify down to 2. So then they are equal. Alright. So as part of environmental, should say study. Let's change that real quick. You need to estimate the number of trees in a 150-acre area. You count 270 trees in a 2-acre area, and notice that the trees seem to be evenly distributed. Estimate the total number of trees. So this is a very practical way of people who actually use proportion. They do it a lot when they try to figure out what the deer population is by only taking a sample size. So there's 150 acres. Okay. Alright, my tablet just stopped writing. Acres. There's 150 acres, and in the 150 acres, we need to know how many trees. So we're going to say that's x. We don't know that. However, we do know in the 2-acre area, there are 270 trees. Now when you're setting up proportions, and I'll be kind of saying this all unit long, you need to be consistent. So notice on the top I have both acres, 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 which is what I want. On the bottom I have all trees because this is X number of trees. I need to be consistent. If I go acres on top, acres over here, trees on top, trees over here. Or I could have went acres and acres, and then I had to go the trees with whatever it went through. Either way, I should be able to solve once I'm consistent. Alright, so cross multiply, I get 2x. And then I can figure out 150 times 270, which is 40,500. Divide by 2 is 20,250 trees. Last, we need to talk about the geometric mean. And a geometric mean is different from the arithmetic mean, which you're used to, where you add them all up and divide by how many they are. Take the sum. Okay. The geometric mean deals with ratios, proportions. It deals with situations when you have to multiply numbers and you're trying to find the mean versus adding, which is the mean you're used to. So when we're trying to find the geometric mean of two numbers, we put the two numbers in opposite corners of the proportion. Then we put x in the other corners. And then we cross multiply. So you're going to end up getting x squared equals a times b. And then we're going to square root both sides. So let's figure that out. So we're going to put 12 over x equals x over 3. And we get x squared equals 36 square root x equals 6. So then on the next one, we're going to go 9 over x equals x over 10. We get x squared equals 90. Alright. And then we can take the square root of 90. Alright. Second square root of 90. Computer wants me to do other things. Sorry. Which is 9.5. Or if I ask you to put in simplest radical form, it turns out to be 3 square root of 10. Alright, so that's it for this video. So remember ratios. They need to be of the same unit. And then when you're solving, this just means ax and bx. How many of the same ratio can we? They go at a consistent amount. If this is 3 and 4, it's how many groups of 3 make groups of 4. Portions, remember you cross multiply, and you need to be the same on when you're setting them up. And then your geometric mean is the x's in the corner and multiply, so you can get x squared equals ab. Reminder to do your reflections. You get credit for watching this video.